Coming up on this episode of the IoT Inc. Business Show.
You see your network having, say, a few hundred nodes. In that case, a private blockchain will work very well. There won't be any major issue. But if you have, say, thousands or millions of nodes, then even the private blockchain will not work. That's why there are two new projects that have recently gained traction, which don't use the blockchain as such, but they use, they are different kind of DLT, distributed ledger technology. One is the IOTA project and the other is the Holochain project.
Okay, our blockchain discussion isn't quite over yet. Let me ask the question again. Is blockchain ready to transact IoT business? The answer is still a resounding no, but let me caveat it by saying there are new technologies that address blockchain's bottlenecks and deployment weaknesses. Introducing alternative DLTs, distributed ledger technologies. In this episode of the IoT Business Show, I speak with Ashish Mehta about the options available for those who want to incorporate blockchain-like functionality into IoT today.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is for business leaders and managers employing the Internet of Things for their business or the business of their customers. I'm your host, Bruce Sinclair, and I interview the industry's leading authorities to find out how they use IoT to improve business and create value. If you like this show, subscribe to it on iTunes and go to iotinc.com to check out my complimentary articles, videos, meetups, and webinars. Well, I thought we were over blockchain, but upon reflection, I didn't really like the way things ended. On a no, definitely not ready for IoT business note. So I called Ashish Mehta of the Cloud Security Alliance to discuss the issue of blockchain scale, or maybe better put, the lack of blockchain scale, to see what, if anything, was being done about it. The call convinced me that one more episode was needed to at least provide a path for those people who wanted to practically dig into blockchain now. So I invited him on the show to continue our conversation. I believe this ties a nice bow around the subject, well, at least for now. As a heads up, note that the next two episodes will be reruns. Good reruns, with two different IoT product design houses. Why? Well, besides not having an episode buffer built up, I'm passing the last mile marker to deliver my entire IoT Inc. certified IoT professional training program, and things, as you can imagine, are very busy. But beta testers are in place and the content's looking great, but there's still a lot of work to finish before the launch. Reason, or is it excuse number 2, is that I'll be keynoting next week in the Dominican Republic of all places. My wife and I are also going to make a mini vacation out of it, so let me know if you have any pointers. And with that, I give you the last blockchain in IoT episode of the miniseries. With me today on the IoT show is Ashish Mehta. Ashish is the chairman of the blockchain working group of the Cloud Security Alliance. He has over a decade of experience managing and developing web and IT security projects and is a contributor to the Ethereum Enterprise Alliance, the IOTA project, and the Energy Web Foundation. Ashish, welcome to the show.
Thank you very much for having me.
So, Ashish, why is the Cloud Security Alliance interested in blockchain?
The thing is, our interest stems initially from IoT, the Internet of Things, but then we took it further because we were very interested in seeing applications which you could use to secure IoT networks. Mm-hmm. So blockchain and other distributed ledger technologies have a lot of potential there. So that's why we started working and we developed a separate working group for for the blockchain space. And we've also developed now two research papers in this space. One is IoT and the blockchain, which will be published end of this month, and the other is the blockchain basic glossary, which also should be ready by end of this month.
Well, great. We will include both those documents in our show analysis notes. And I have taken a look at the first document, and it's quite extensive and very technical. But I think it is interesting because your route to blockchain was through IoT, which is obviously perfect for this show. Well, why don't you give us a little bit of an idea of your background in IoT and a little bit more about yourself?
Yeah, my first experience in IoT, it revolved around programming SCADA PLCs for a number of electrical utilities in the US, as well as developing Profibus and microcontroller-based solutions for a semiconductor company in Chicago. From there, I branched out into web development and had a particular fascination for web application security and GRC projects, governance, risk, compliance. From there, then I took it further and started contributing and writing for multiple technology blogs, as well as writing research papers for a boutique analyst firm in India. So my last paper there was focused on the IoT. It was IoT in the telecom space.
Nice.
And
nice.
From there, it's around the same time that I joined the Cloud Security Alliance. I joined the IoT working group initially, and we started working, and we came to an understanding that yes, there is a need to develop a separate working group because as I'm sure your audience also realizes, IoT is a very vast subject today. So we wanted something separately. That's why we branched out and set up our own blockchain working group. So in addition to chairing that blockchain working group, I'm also heading their IoT standards consortia right now. So my job there is to talk to various IoT standards globally. And because see, what happens is all standards, they don't I would say some compete, some collaborate. So you bring everything onto the same page for our wider CSA community. That's where I step in, because US has one set of standards through NIST, then Europe has something different. In some places they're common, but they're not always common. Asia Pacific, in Japan, they have something different. So how do we bring all that together? That's a very a tough thing, which I'm trying to do.
Now, talk to me a little bit more about the standards. Which standards in particular are you talking about? Or what type of class? Or what type? The class of standards.
NIST standards. Then
okay. So more security on the security side, then.
Exactly, on the security side, because we are the Cloud Security Alliance. So security, everything what we do,
right.
Security is a primary factor in that.
Well, let's so obviously then the Cloud Security Alliance came across blockchain. Blockchain provided a certain type of security. Why don't you maybe clarify for our listeners, what does blockchain bring from a security point of view, and what does it not bring from a security point of view?
Sure. See, the idea was that because blockchains are immutable and decentralized, you could use the blockchain to ensure that you as a corporation or an IT executive team have full control over the various IoT devices in your enterprise. So what that would do is it would prevent IoT focused attacks, which were very prominent attacks. Last year we had the Mirai botnet attack. This year we had the BreakerBot attack, the Hajime attack. So these attacks, so the problem with these attacks is nobody had any clue who has hijacked those IoT devices and who is controlling them. And they're just basically out of your control. And now what has happened is shadow IT has become a very big part of IT of the enterprise setup, because a lot of enterprise users, they could be standard users. They're bringing their own IoT devices into the enterprise IT setup, and they expect to be able to use it equivalent. I would say it's a progression to the BYOD phase. Bring your own device. Is a progression to that. But previously it was just bringing a smartphone. Now people want to bring smartwatches, and they say like, no, I should be able to connect to the corporate network. And then then it's like then smartwatch. You have it's a long list. I mean, there are, you could bring a drone. You could do whatever you want. So the thing is, so where blockchain steps in here is if you're able to allocate each and every IoT device onto a blockchain node, and then because that node is decentralized and it's immutable, you're able to control each and every node in your blockchain. And so what happens is, let's say a node is hijacked, a device is hijacked, or let's say it just breaks down because of a misconfigured update. You should be able to identify it and shut it down without putting off your network. Your network should not be affected.
But I'm trying to understand now. If we're talking about security, there's a couple obvious, directions. Blockchain, I don't think helps with the confidentiality of the data. I don't think it helps with the accessibility of the data. But really, at least my understanding is it's more on the integrity of the data, just making sure that it has not been altered. Am I misunderstanding that, or can you maybe shed a little bit more light?
No, see, the thing is, what happens is conventional blockchains, what we call public blockchains, they're confidential. There are four big public blockchains. One is the Bitcoin blockchain, then there is the Ethereum blockchain, then we have the Ripple blockchain, and we have the Hyperledger from IBM blockchain. So if these blockchains are used in the public space, then you're right. You are not able to handle confidentiality issues effectively. But if you're using the same blockchain in a private or a semi-permissioned space, then yes, you can take care of confidentiality issues as well. So
how is that done though?
Because you are the one who decides which node is connecting where, and you have ultimate control over the network, the blockchain network.
Now the blockchain is protecting, the blockchain is identifying the data. In this case, as you were saying, the example was you put all your end nodes in a blockchain. So your end nodes then are producing data.
Correct.
And so then what you're saying is because the end nodes are in the blockchain, you know where they are, you know what they're connected to, and so that doesn't change. So from a confidentiality point of view, what you're saying is potentially if there's been a change in that topology, or like how is it preventing an attack on the data itself?
What happens is you have this is something which is now being developed in I would call them the second layer of blockchains. So you have three separate blockchains that have come about. One is the Factum Foundation. So they have built on the Bitcoin blockchain, they have built their own Factum blockchains. So those are all hashed, and they have separate hashing capabilities there. But because it's only anchored to the Bitcoin blockchain, and it doesn't depend on your the speed and scaling issue is not an issue there.
Okay. So what you're saying then is if you add a secondary blockchain, correct, such as Factum, then you can use that and the hashing, and in that case then you're hashing the actual data as opposed to the device itself. Am I understanding that correctly?
Yes.
Okay. And so then it's a hash within a hash. You've got the hash, which is the encryption, and so this is what prevents this is what stops, I guess, from a confidentiality point of view. So you have the encryption, and then you have the encryption of the device, but that's more for just this immutability, or just making sure that nothing has been changed to the data along the way. And then the second blockchain, what you're saying, actually does encrypt the data itself. Is that a good way of thinking about it?
Yes, that's the good way of thinking of it. Yes, correct.
Okay. Well, I want to get into scale. You did mention scale, and as you know, I've been having a number of interviews and kind of learning with the audience together what blockchain is, and in particular, the angle is blockchain ready for business, and should we be looking at it from an investment point of view? And one of the things that came up, and I more or less came to the conclusion that no, at least in its current form, blockchain is not ready. And one of the biggest issues was scalability. So can you maybe shed some light, Ashish, on the current problems with scale for the distributed ledger or the DLT, the distributed ledger technology?
See, the scale in public blockchains, it's a very serious issue. You wouldn't want to use them for enterprise projects today. In the private blockchain space, private or semi-permission, what we say blockchain space, it's not that big an issue because it all depends actually. See, first of all, you have to visualize how many nodes do you see your network having. Do you see your network having, say, a few hundred nodes? In that case, a private blockchain will work very well. There won't be any major issue. But if you have, say, thousands or millions of nodes, then even the private blockchain will not work. That's why there are two new projects that have recently gained traction, which don't use the blockchain as such, but they use they are different kind of distributed DLT, distributed ledger technology. One is the IOTA project, and the other is the Holochain project. So at the Cloud Security Alliance, we've had the good fortune of working with both of them. And in one word, I can tell you that they work. Both technologies work, and they've demonstrated very good use cases also.
Well, Ashish, before you go into IOTA and the Hyperledger, which I am interested in,
yes,
you made the statement that when it's a public blockchain, you got troubles with scale, and when it's a private one, you don't. And the reason is the number of nodes, right? And so that implies that, I mean, obviously, if a private blockchain was thousands or tens of thousands of nodes, would you have the same problems as the public blockchain? So it's not really an issue in the technology; it's just the issue of the number of nodes. Is that the metric that we're looking at?
Yes, because what happens is in the blockchain, you have to technically, what do you have to do? You have to verify each and every single node of the blockchain for integrity. So this is what causes the problem in a public blockchain, because the node could be all over the nodes could be all over the world. That's why the Bitcoin project, Bitcoin as a currency is struggling with such heavy transaction costs. Even Ethereum recently, now it's to build a simple smart contract on the public Ethereum, it costs close to $8 today, so per contract. So that has become very expensive because of the same reason. You have to verify nodes all over the world, and it's not easy. The node could be anywhere in the world, and what is the guarantee that the node is on when you want to verify it? There's no guarantee. Yeah.
Okay. So this is helpful. So what you're saying is, on a public blockchain, essentially you don't have control over the network or the computing devices, and therefore, right, you could have it could be on a very slow network, or it could be on a very far network, or it could be on a very slow device. But whatever the case is, you have to wait for the last, which will be the slowest of the networks or of the computing devices to finish it. Is that correct?
Yes, correct.
Okay, and then alternatively, if you're in a private network or a private blockchain, you have control. You have control. Yeah. You make sure that everyone has powerful enough computers. You make sure everyone has good enough connections, and are close enough, let's say, just in terms of just using distance as an issue too. So so I get that, and that's really useful because we've been trying to hack away at what these metrics are, and now I'm getting it. So we we now have a more controlled network. So why do we need then these new BLCs? I don't know if I would call are they
DLT. It's
BLTs? I'm
DLT.
sorry, are
Yeah.
distributed
Ledger
blockchain
technology.
distributed ledger
Yeah.
technology DLT. Why do we need
Yeah.
these new DLTs from IOTA and from the Hyperledger?
Holochain project. No, from Holochain project.
Oh, Holochain project. Okay.
Yes. So the thing is, in even if in these conventional private networks, as I told you, they are not the it's if you have to use like say thousands or millions of nodes, then it will not scale. I mean, you will struggle even in a private. But
Sure.
if you
Okay.
so that's the one main thing, and the other thing is the data exchanged. So so there are restrictions on the data on the amount of data you can exchange between each node in even in a private blockchain. You won't be able to easily exchange a lot of data. Like if I had to give you an example of say a smart car where you want to try to do over the air charging of the car or updates, or you want to do analysis and all that. So the analysis and there are multiple things you can do, but you won't be able to do it very effectively over a private blockchain also if you have a lot of nodes. I'm talking about say you have a 10,000 for example 10,000 Tesla cars, and you want to see how they're charging, where they're charging, and remaining other metrics. How is the battery performing on highways? How is it performing on steep roads, city driving, and that kind of stuff. If you want to do, how is your engine handling everything? Different weather conditions. So
Okay.
for that that's where the IOTA project comes in. So and that has been configured specifically for IoT networks. And the good thing is what they have done is, apart from showing you successful use cases, the other thing they've also done is they have set up a developer fund of $2 million. You come to them, you go to them with a proof of concept, and they will fund you.
Okay, and fund you, but they must have some constraints in that funding.
And they will fund you on the project. I mean, they will that you have to use IOTA in their project, but so that is the main concern right now. They want to build as many use cases as they can as quickly as possible.
Okay, so then if we dig down a little bit deeper, I think what you're saying is the actual verification. So this is what they call the mining, right? The mining. You're saying then with IOTA and the Holochain project, they have different mechanisms for this proof of
work. Correct.
Of work. Then is that really where it comes down to the differences from a technology point of view?
Yes. Because they are not blockchain. They are the IOTA is called as a DAG. It's a directed acyclic graph. It's a tangle.
I'm aware of them. Yeah.
Yeah, the protocol is called Tangle protocol. So the way they verify the nodes and the transmit data is much faster and much simpler than doing it over the entire blockchain. So I mean, you could.
But then, if we're using a DAG protocol or the Tangle protocol for DAG versus whatever protocol for DLT, are we not losing then some of the benefits of what brought blockchain to the forefront of everyone's discussions, and made it so hyped up? I mean, we must be losing something then if it's not really blockchain or
no, you're not, because the thing is, because this network is also decentralized. It's also immutable. It's and it gives you an additional second layer of functionality, protocol, which improves the functionality, and you're able to send and receive a lot of data over the Tangle, and it's irrespective of the cost of the device or the size of the message. So
okay.
Yeah, it really doesn't matter. I mean, because the way they have built the network is such that cost is not an issue when you're transmitting messages.
And the cost, again, is being associated with the proof of work. And in the past,
Right.
this proof of work was solving this cryptographic mathematical equation.
Right.
And now it's using different ones. Okay, so
Yeah.
you were starting to get onto a use case, but before you go there, you mentioned something earlier which is very important to everyone listening from my perspective, and that is smart contracts. Can you maybe, first of all, just give us a bit of a definition of smart contracts and then talk to us about how, and from my understanding is Ethereum, that's what it's more or less based on. It's a big state machine that allows you to develop these smart contracts. But give us a bit of a definition of smart contracts and tell us why it's challenging with DLTs versus with these with the new DAG or with the holochain technical infrastructure.
A smart contract would be a very simple and computationally robust way to enforce an agreement between two different parties.
Mm-hmm.
So the thing is, when you're signing a conventional contract on paper, you have multiple papers which have to be exchanged all over the place. But a smart contract is configured in such a way that the protocol does everything for you. All you need to do is set up the contract, and both nodes take care of all the hassle for you, and they will update it in the ledger. They will transmit the data between different nodes on different registries. Everything will be done by the contract. You just have to program it once, and this is where Ethereum excels.
Mm-hmm.
The smart contract, because the basis of Ethereum was the smart contract programming.
So and I think just to clarify for everyone listening, a smart contract again is not a legal document. It's a piece of code, and the piece of code encodes obviously the relationship and the rules with the relationship. And what you're saying then is the code is, let's say, compiled down and then executed and takes care of all the DLT or the equivalent of DLT activities. Is that what it happens?
Yes. I mean, you have to manage the relationship effectively, and that's what a smart contract does between two parties. And that relationship is also very robust and immutable. Once it's built, it's built. I mean, it's done. You can't break the contract.
Right, because then it's distributed in a DLT or the equivalent of a DLT, and that's what gives it that immutability.
Correct.
So let me, for me, when I first started learning about blockchain and in particular the distributed ledger technology, immediately what I saw its killer app would be to use it to monetize, or at least be the mechanism to monetize ecosystems. Because an ecosystem is going to be a contract between multiple vendors and to supply a solution to a customer. So the IoT technology is going to orchestrate various products to deliver an outcome. That outcome then is sold as an outcome, and then the parties involved are remunerated from the customer. So to me, this sounded like the perfect, situation, the killer app for a smart contract. Because right now to do it, and I've had experience with my clients, this is a big bundle of legal expense because it is effectively a middleman. It's got all the hallmarks of what blockchain theoretically eliminates. It has the middleman, it has the costs, and if we can encode that in terms of software and eliminate that middleman, and then even furthermore, then distribute it so it's immutable. To me, that sounded like the perfect use case for it. What do you think? Is that true, or am I missing something here?
No, that's accurate. I mean, there are a lot of companies which have launched projects along lines. Like I could give you the example of a Russian airline, S7 airline. They've built in the Ethereum blockchain only smart contracts for booking and reserving flight tickets between the travel agent and the online web console and their main database. So everything is being done via an Ethereum blockchain today.
Okay.
And what they say is they've been able to reduce costs by close to 30%.
Now, so let's break this down a little bit then. So what is, first of all, you're saying it is using a distributed ledger technology between the travel agent and the database.
Correct.
First of all, I guess my first question is why even use blockchain in this situation? What is it trying to prevent, or what's it trying to save?
Then basically, you don't need to maintain a single database, right, in one place.
Okay.
So then it's an added expense. I mean, if you're trying to maintain one single database in one place, then you need that level of security, you need that level of manpower, those kind of resources. But if that same database with all the client information is scattered in nodes in different even if it's a private blockchain, it doesn't matter. As long as it's a decentralized and distributed node, a network, then that gives it that level of robustness. And the chances of, say, somebody hacking and stealing your list are very, very slim in that case. I mean, this is something which I'm sure a lot of your listeners are quite worried about. What happens if somebody breaks into my company database and takes away all of our precious client information? It's happened very frequently and very often in the last 2-3 years. So,
but Ashish, to kind of go on that point, what we're doing here is we are distributing the database. So that
correct.
means there is a version of the database on, in this case, I guess the travel agents maybe, or the online booking sites. So if a hacker then could actually get the same database, could they not, by just hacking the travel agent?
No, the thing is, see, when you design a private blockchain, in that you can design security also, that if one node is affected by any reason, you can shut down that node. So that can be done even in an Ethereum blockchain. It can be done. So the moment, say, they feel, okay, this node is compromised, they can shut it down.
Okay, and that's because of the code, which I want to get to in a moment. So that's because you can add some logic to the events themselves?
Right.
Okay, so what you're saying then is the reason for doing it in this particular use case with the Russian airline is one of saving money and also creating a more robust database that's less hackable. Does that summarize it?
Right.
Okay, so now let's talk about the smart contract. Let's, using this example, what is the smart contract and what does it do in this situation?
It builds the relationship between the customer who's buying the ticket and the airline, and that contract is verified on the Ethereum blockchain.
Okay, so then it's basically saying, okay, customer, you're buying this ticket for, the current rate. So it looks at some, again, I don't know where that database is, but it looks at some database and it finds the current rate, because these are dynamically priced products. It finds the current rate and then it encodes that rate. So it's basically, the smart contract is a traditional contract of encoding a transaction between the airline and the travel agent, or the airline and the travel agent website. Is that right?
Yes.
Okay. And so then the idea is, now that we've encoded a transaction into the blockchain, what's the advantage now of doing that versus just using it, let's say, as a traditional blockchain, not an Ethereum-based DLT?
The smart contracts are much, because Ethereum is designed specifically for smart contracts, they are much more easier, and the solution is technically more elegant in an Ethereum blockchain.
Okay.
I mean, you could also do it in a conventional Bitcoin blockchain, but the solution will not be as elegant as it will be in an Ethereum blockchain.
So in this case, I think what you're saying is you can
simpler programming.
Simpler programming. So it's simpler programming, and you're combining both the database functionality and the application functionality in one. Yeah.
Right. Yes.
Okay, and that's what makes it a little bit simpler, maybe a little bit more efficient, and a little bit more, I guess, resilient to tampering.
Right,
All
right.
right.
And the thing is, there's a fundamental rule in software coding. The more code you have, the more chances it has of going wrong. So
True.
that's you want to keep it as simple as short as possible, because
That's
then
right.
it's a very fundamental rule of software development. Like I'm sure most of your listeners who have experience in software development will agree that you want elegant solutions. I mean, simple solution.
Yeah, and this is kind of, something when in my day when I was a professional programmer,
Correct.
we had to write everything from scratch pretty much. We just had a few libraries. In my case, it was graphic programming libraries to be able to display, on certain types of workstations. But now there's so many libraries that are available on GitHub and just on the internet in general. It kind of exuberates this problem, doesn't it? Because now you can whip up a mobile app, or let's say even certain forms of IoT apps relatively quickly, because you're building upon the shoulders of all these other programmers who have built these libraries. And
Right.
so in terms of code size, if you're to, let's say, develop this application, use maybe an open source library from here, another library from here, you're just getting a lot of code, but it's relatively simple to program because you're using these APIs. So I can see what you're saying in terms of the simplicity, and I
And
like it conceptually.
yeah, and what happens is, because this is open source code, it has already been peer reviewed multiple times. Not only has it been peer reviewed, but also there have been a lot of what I'm looking for is, white hat attacks also. I mean,
Mm-hmm.
sense.
Mm-hmm.
So they have verified that okay, there is if there's a problem, then and they identify the problem, they contact the company, and companies also launch a lot of bug bounties. Like IOTA Alliance also has a bug bounty, Ethereum also has a bug bounty. So the thing is, so the moment a problem arises, within I would say 15 days to a month, you're able to catch that problem and fix it. That's the advantage with this kind of code. But the thing is, if you look at it to legacy systems, like your big enterprise ERPs, which are all closed source, they are. I'm sure your listeners also must be tracking this, but that the the bug will be there in the code for 6 months at a stretch,
Mm-hmm.
sometimes even more, but it won't be patched. Why it won't be patched? Because first the company which is producing the code is scared, like if I fix this, will it affect something else somewhere? And then the enterprise IT department is scared, like okay, the applications we have built up on that ERP system, or it could be a CRM system, will be affected. So let's hold off patching. So in that journey, you lose sometimes 6 months and a year, like, and a lot of vulnerabilities that come out now are because of this only. Like you for a hacker today, for a professional black hat hacker, or he could be somebody who's just searching for some extra money, it's very easy, today. I mean, all he has to do is look up the CV database, that okay, these are the vulnerabilities, and then just access any public facing component of an ERP system or a CRM, and he will get into that system very easily today. It's very easy. Any professional hacker can do it.
Now, how does DLT or equivalent DLT help with this situation? Because you still have don't you still have the same human issues?
The DLT, as I said previously, will be patched faster. That's something that will happen, and the yeah, it won't. I mean, to that extent, because the patching. No, the patching happens dynamically, so it won't. You have no choice. I mean, you have to patch as
Right.
the
In fact, you're not even patching. The patch is happening, and then you're just using the code that happens
Correct.
to be patched, right?
Yes, you're right. Because the thing is, very recently, about 3 months back, there was a bug exposed in the IOTA code. So the bug was exposed by a bug bounty hunter, and he disclosed this thing bug to the IOTA consortium, and within a month, not month, it was I think 15 days, 2 weeks, they fixed the code and they release the code, to the release the patched code to your to all the users, and then they announced, okay, there was this vulnerability and we have fixed it.
Right. So unless
But the same,
unless that patch is on the client side, then the client user doesn't have to worry about it, right?
correct. Yes.
Now, this kind of sounds like a service, and so I guess I've heard of something called blockchain as a service. What does that mean?
Right.
Is that related? Is that related to what we're talking about now, or is it something different?
Yeah, it's related to what we're talking about now, and what kind of services you could leverage off the blockchain. The blockchain will be there. It's a distributed ledger system technology, and what kind of services you could leverage. It could be smart contracts. It could be that's how they visualize. It could be running an inventory management system. It could be just looking at various aspects of some system somewhere, or you could do like you have multiple IoT nodes, what each node is doing where. So you could technically, through a blockchain as a service, you could do all this. So, I mean, so what happens is maintenance of that blockchain as well as control of the blockchain rests with the party who is offering you the service. You are not responsible for that.
Okay. And what's your responsibility? Because again, the blockchain is a distributed ledger. The code, then, I'm just trying to think here. What you're talking about is the code is now going to live in the cloud somewhere as
Right.
opposed to on-prem. Is that the difference?
Yeah.
And so when it's on-prem,
Yes.
then you have to maintain it?
Right. Exactly. That's a very good way of looking at things. Yes.
So blockchain as a service is like the name implies, and then is it a generalized service or is it focused on particular needs or all the above?
I mean, yeah, all of the above, because right
Okay.
now it's something which is just being developed. Because see, to run a service like this, you would typically need somebody who has a lot of resources, like the Amazon or Microsoft or IBM. So they're still rolling out their service. So you don't, I mean, even if they are saying like, okay, it's ready, it's not ready today. They're rolling out the service and they're trying, because in the case of Microsoft, they've launched something called a Cocoa framework for blockchain. So, but even that, they've just released the concept paper today. The main code in that will be out sometime next year in March or April.
Okay. Well,
So
I mean, go ahead.
yeah, so what happens is, if you're expecting like something very similar to cloud as a service, could be SaaS or could be IaaS, infrastructure as a service, right? I mean, it fits perfectly. Blockchain as a service fits perfectly with infrastructure as a service. So that will still take time. That's not ready right now. No, it's not.
Okay. But I like the concept. I mean, with the possible exception of it maybe adding an extra layer of indirection and therefore affecting the performance slightly, but the concept makes a lot of sense to me.
Right. I mean, for a lot of enterprises, see, I mean, if you look at it from the technology innovation curve, the guys, the corporations who are leading or early adopters, they would typically tend to already have at least one small blockchain or project in house. But the majority of the bell curve is the guys who are mainstream adopters. Like when it becomes mainstream, then only they'll adopt. For those kind of companies, this kind of a service will make a lot of sense. Blockchain as a
Okay.
service.
Yeah, no, it does make sense. And I want to get to the question of ready now. But before I ask you about that, Are there, I like to include some links in the show analysis notes, but can you give us some examples off the top of your mind, or you can just provide me links after the fact, but are there any examples that we could point our listeners to show, I guess, the promise of blockchain as a service?
Yeah, sure. I could share them with you. I mean, there are a couple. I could share them with you. Definitely.
Then everyone, we'll put those in the show analysis notes because this sounds promising to me. But now I want to get to the question of ready. So as I started out the show, I mentioned that I came to the conclusion based on the traditional DLT, distributed ledger technology, that it's just not ready. It's not ready. It's not ready for prime time. It's not ready for business. Now you've introduced a couple companies, projects to us, IOTA and the Holochain project, which are different but kind of follow the same philosophy, this distributed ledger. My question is, are they ready for business? And the real question is, everyone's listening and they're wondering, should I be paying attention to this now? Should I be budgeting for this now? Or should I just be paying, maybe a better word is, should I just be keeping on top of it rather than executing some manpower and capital resources to it? So my question is, even with these new pseudo DLTs, I'll call them, not in a bad way, but these pseudo DLTs, are they ready? Are they ready to be used today for business?
Yeah, the IOTA project is ready because they've demonstrated good use cases also. So they are ready, and they've demonstrated very different and very varied cases. Like there's one case where they're working with a company called Paragon. So they are a marijuana startup in California. So what they're trying to do is create a transparent and verifiable database to give the cannabis industry in the US greater legitimacy. What happens is not every state in America, cannabis is legal. Marijuana is not legal in every state in America. So the states where it is legal, there are also some physicians who prescribe marijuana, medical marijuana.
Sure.
So So how do you ensure the quality control of your product, as well as cutting the transaction cost from the producer to the seller and finally to the end user? So this is something where Paragon has been able to develop very, very, very interesting use case.
Okay, so what you're talking about here is a supply chain use case.
Correct, yes.
And what I'm asking, I guess, is, and I've been trying to get at this, and I think I know the answer, but okay, a supply chain, let's say there's maybe 10, I don't know, I'll be really generous, say 20 points of contact that need to be encoded into the DLT for a supply chain. To me, that's not a very big number. One, am I correct in that? And that is not a big number. So I guess what I'm wondering, what my real question is what's the metric? And it sounds like the metric is the number of nodes that need to be encoded within the DLT or the DLT-like technology. So are we talking it's feasible with IOTA and the Holochain project to do 10, 20, 100, 1,000? Give us some numbers here, because everyone listening is going to have their own number of nodes, and they have to make their own decisions. It's not just one fit.
Yeah, you can do 1,000, over 1,000 nodes. It won't be an issue.
Okay, so over 1,000 nodes.
Yeah.
So that's around. So the state of the art. Here we are in November of 2017. The state of the art, what you're saying is, if a company has got, let's say, 1,000 nodes or under, they can effectively use blockchain-like technology today. Is that right?
Yes.
Okay. No, that's helpful. That's helpful, Ashish. All right, yeah. Ashish, can you talk to us a little bit more about your project, specifically the working group on the Cloud Security Alliance, and tell people where they can find more about that project and those documents that you were talking about earlier?
Sure. As I said in the initial stage, initial beginning of this talk, that we were also grappling with the same issues because the CSA is a group of developers, engineers, and basically IT professionals who are also focused on solving the same issues. So what we also realized that there is no freely accessible resource in the market today which tackles both these issues, IoT and the blockchain effectively,
Mm-hmm.
and brings it into a simple format, simple and easy to read format for a technically savvy but not too technically savvy also audience. I mean, a lot of the audience doesn't, I mean, especially those people who are slightly higher up in the corporate ladder, they are not that interested in the nitty gritties of the technology. I mean, why is this using MQTT, and why is this not using is this masked MAM, masked authenticated messaging network, or whatever. They're not that interested in that. What they're more interested in is, firstly, is does it work? Secondly, if it's working, yeah, how does it work? I mean, just the basic idea, and then they want to see some use cases in action. So that's what we've tried to put in together in one paper. And my colleague, who's the lead author on that, Mr. Sabri Khamisa, he is an ID management specialist based in France.
Mm.
Yeah, I can't, I mean, talk about the company which he is which he was attached to, because he is not allowed me to disclose that. But the thing is, his main interest was in ID management only, in the sense, you mm,
It's
can you do
important.
this
Yep.
effectively? Can you do this effectively or not? So the conclusion which we have come to is, yes, you can do it. You can do it effectively, and there are use cases today, and the technology is ready today to do it.
Okay. So now you mentioned there are two documents. One of them, are we able to link to those documents yet?
No, they'll be published end of this month, not yet. But I can definitely share them with your audience offline. If they contact me, I could give you basically, it's last minute polishing and copy editing, that kind of stuff is left. So that will be ready end of this month. But I can definitely share the draft with you, with anyone.
Okay.
They
And
contact me. Sure.
that sounds good. And then also what we'll do, because there'll be many listeners that are going to be listening to this show far later in the future, when they are ready, we will include them in the show analysis notes, or links to them in the show analysis notes. So I'll just
Sure.
ask you to send me the public links when they're available, and I'll
Right.
include them in the notes. Okay. And
Absolutely.
then if people do want to discuss this with you, they should contact you through the Cloud Security Alliance.
You can contact me directly as well on Twitter. My handle is AUM underscore block. One more thing, Bruce. Hi.
Hmm?
Yeah, the thing is, we are working on another paper of use cases for DLTs and blockchain and non-blockchain DLTs. But that paper will be ready only next year in February.
Okay.
So
And this is the
everyone,
second of the two papers we've been talking about, is it? Or is it a third
no,
paper?
this is a third paper. The
Ah, okay.
Yeah, so this is something we're working on right now, and we're very excited about this paper also, because this is something which when you're pitching to say, let's say you're an so you're a project manager, and when you're pitching it to your CFO or your CIO, like the first question he asks, has somebody else done it? Then you can you just show him the list. Okay, this company has done this with this blockchain, with this technology they've used, and so we are very excited about that paper also. But that's right now in documentation stage, so it'll be ready by February. If your listeners are interested, I can share what all we have documented also, if they contact me directly through Twitter, or they could definitely join our working group That is also a good option. So I mean, it's cloudsecurityalliance.org/projects/blockchain.
Okay. Well, we'll put that, Ashish, also in the show analysis notes. And just to be clear, give everybody just the name of the 3 documents that we've been referring to.
Right. The first document is IoT and the blockchain.
Okay.
The second is blockchain glossary.
Okay, got it.
And the number 3 is successful use cases in blockchain and non-blockchain DLTs.
Perfect. Okay, Ashish, I appreciate the time. Thank you. Okay, well, that was episode 96. Another great number. To get analysis of this episode, and there's lots of links in it, so to get the links that were mentioned plus the transcript, go to the show analysis notes. They can all be found at iot-inc.com/podcast. If you want to get all the transcripts for all the podcasts and videos, just join my private reserve. The way you do that is you sign in with the long version of the form. If you've been enjoying this podcast, subscribe to it. That way you'll get every episode delivered into your mobile device. And if you like to support it, there's 3 ways you can do that. Share it on your blog, either personal or company, if you think others will find it of value. You can share it on social. You can do that with some social buttons that are in the page on the bottom or the left, depending if you're looking at it with a desktop or a mobile device. And you can leave a rating or review on iTunes. I know I say this every time, but I'd really appreciate it. Just go to iot-inc.com/iTunes-. There you'll get some instructions, because sometimes it's not that easy to do, or at least not obvious to do, but it only takes 1 click once you're there, and a little bit longer if you want to write your thoughts. I'm your host, Bruce Sinclair. Thank you for listening. Until next time, may your path to IoT business be a distributed one.
You have been listening to the IoT Inc. Business Show.